People, here's your video for the review guide for the conic sections. Okay, I'm going to work through a few of the parabola. Probably work through a few of each of them. I'm not going to do every single problem because they're very similar. And the definitions and such, you can look those up from your notes packet, okay, because you should have those from class. So I'll spend time kind of doing a lot of the algebra type stuff and the graphing, so that way you guys know what you're doing. Okay, so on the first one here, that I'm going to work through, the parabola here, you want to change it to an x equals or a y equals. And right now you have the 5 over there on the left-hand side. So the first thing you want to do is to move that 5 over. And you cannot add it to the 4 that's inside the parentheses because it's inside parentheses. It's separate. Okay? So you just have to add it on the back end. Alright, so it would look like that. That's the equation right there that you want to graph. Okay? So you can get some information. Remember from class, we want our vertex, axis of symmetry, we want our focus, we want our directrix. We need all that information, and then we also need an XY chart for this, okay? And since this is an x equals, we'll be plugging into the y value, okay? So, vertex is kind of backwards since it's x equals. That's my h, and that's my k, all right? So it would be a 5, negative 4 for the vertex. And then we can kind of fill out the rest of the stuff here from that vertex. So since it's an x equals here, since it's x equals, then you're going to go with the y value for your axis of symmetry. So it's y equals negative 4. Okay? And then we can use our equations for our focus and directrix. Since this is an x equals, your focus is going to be adding to the x. So that's the equation for the focus. And this is the equation for the directrix. So we found the 1 over 4a in class, we added it for the focus, and we subtracted it for the directrix, okay? So my 1 over 4a is going to be 1 over 4 times 2, which is 1/8, all right? So for the focus, we're going to add an 1/8 to the x value, which is at 5. We're going to add 1/8 to that. So it would be 5 1/8, or 5.125, comma negative 4. And then for the directrix, it's going to be x equals, we subtract that from the 5. So it'll be 4.875. And remember, the focus is the point, the directrix is a line. And then we can fill out the xy chart, but I'm going to graph what I have right now. So my vertex is 5, negative 4 right there. And my directrix is it's just going to be a line behind it, so you're not going to be able to get a great estimate of the line. And then the focus is a line on the or a dot on the inside, sorry. And for the xy chart now, since this negative 4 is my y value, we know we're plugging stuff into the y here, so we want to pick points close to that, or points close to your axis of symmetry. Okay, so it's negative 4. So we want a negative 3 and a negative 2 as the two values to plug into the chart. Okay? The negative 3 plugs in there, so it's negative 3 plus 4, which is a 1. Square it, that's still a 1 times 2. That's a 2 plus a 5, that's 7. Plug in the negative 2. Negative 2 plus 4 is 2 squared, that's 4 times 2, that's 8 plus 5, that's 13. So those are the points that we want to graph. Okay? So 7, negative 3 right there, and we can reflect that point there. And then 13, it's kind of off the graph. I'll do it with a different color so we can kind of see it. 13, so that's 11, 12, 13, negative 2, so I'll be here. And then I can reflect that one down here. And then draw the parabola. All right? Okay, on to the second parabola here. This one is already written in vertex form for you, or standard form, whatever you want to call it, because it's an x equals. You're going to have an x equals or a y equals for parabola. Okay, so we can identify all of our pieces here. We need vertex, axis of symmetry, focus, and directrix again. All right, my vertex here is a negative 1, negative 4. Remember, it's always h, k, there like that. Axis of symmetry, since it's an x equals, we need y equals negative 4. focus, we need the 1 over 4a. So it's a negative 1/8. So for the focus, we're going to add a negative 1/8 to the x value. Okay, so this would be negative 1 and 1/8, or negative 9/8, comma, negative 4. And my directrix will be the other way, so it'll be an x equals negative 7/8. All right, so that's the information we need for all the extra pieces. We need an xy chart, and we need points close to the y value when we're plugging in stuff to the xy chart. So we want a negative 3 and a negative 2. Plug those two values in. So plugging in a negative 3 into there, so it's negative 3 plus 4 is a 1. Square it's still a 1, so negative 2 minus 1, got a negative 3. Plugging in a negative 2 now, so negative 2 plus 4 is a 2. Square it, that's 4. Times the negative 2, that's negative 8, minus 1, negative 9. So now we have enough pieces of the puzzle to graph our parabola. All right, so my vertex, negative 1, negative 4 is there. I know it's opening left. Okay, so negative 3 is from my xy chart, and then negative 9, negative 2 is also from my xy chart. All right, so this is the graph of my parabola. We need focus and directrix. So directrix is negative 7/8, so that's really close to the vertex right here. So that's the directrix. And then my focus will be kind of on the inside there. Just like that. And that is your other parabola, okay? So I'll do one of these y equals parabolas down here, and then I'll jump to, well, after I do the algebra one down here, I'll jump to the circles next, I think. Okay, so let's do the one on the left here. Number 4. Okay, we know that it's a negative a, so it's going to open down. Vertex here, it's like normal again, so it's 2, negative 4. Axis of symmetry, since it's a y equals, we're going to use the x value, so x equals 2. Focus and directrix, we've got to do the 1 over 4a. And that's a negative 3, so it's a negative 1/12. So that's just barely away from the vertex there. Okay, so we'll have, since it's a y equals here, we've got to add to the y value. Okay, so we're going to add our focus value, or 1 over 4a, to that negative 4. So it'd be negative 4 and 1/12, or, okay, so it'll be 2, comma, negative 4 and 1/12, or that'll be 12, 24, 30, 49 twelfths, negative 49 twelfths. And then that means this is going to be a y equals 47 twelfths, so negative 47 twelfths. Because for the focus, you'll add this negative 1 over 12, and for the directrix, you'll subtract that from the y value of your vertex. Okay? And xy chart, I'll throw it off to the side over here. Back to normal, so we can plug in points to x that are close to our x value up here. So it's close to 2. So that would be a 1 and a 0. Put in a 1. 1 minus 2, negative 1 squared. Back to positive 1. Times the negative 3 is a negative 3 minus 4 is negative 7. And plugging in that 0. So 0 minus 2 is negative 2. Square it, that's 4. Times the negative 3, that's negative 12. That's negative 16. So that one kind of gets big pretty quick. All right, so 1 or 2, negative 4 is my vertex. And 1, negative 7. And then 0, negative 16. We'll just say it's down there. Kind of like that. Missed it a little bit, but that's okay. And we can plot our focus and our directrix here. So our directrix is only going to be 1/12 away above here, so you won't really be able to see it on the graph. It's pretty much going to look like it's right on there. And the focus is also going to be 1/12 away right inside there. Okay? So that's all I kind of expect on the test. You just have your directrix kind of close to that, and then your focus, I got to see a point on the inside there. All right? So those are the graphs of the parabolas. Let's take care of this bottom equation one here. We should be getting decent at these because we have done plenty of them. Okay, vertex is that. Focus is 2, 7. So you got to ask yourself again, which is this going to be, an x equals or y equals? Well, you got to look at the point or the value that changes for the points. If I'm going from a 2, 6 to a 2, 7, so the 6 goes to a 7. That means it's a y equals. Okay, so y equals a x minus h squared plus k. Okay, since it's a y equals, we also know that we have to add to the focus and the y value. So it'd be h k plus 1 over 4a. So this is what we're going to have to use to make an equation. All right, so we know our focus down here, we're given 7. So that is equivalent to this stuff. So 7 equals k, which is a 6, plus 1 over 4a. Now we can solve that for a. So subtract 6. You get 1 equals 1 over 4a. To get the 4a out of the bottom, we have to multiply by it. All right, so we cancel here. We get 4a equals 1. A equals 1/4. Take that, plug it in. Okay? And we also have the h and the k from the vertex that was given in the original problem. So we have 1/4 x minus 2 squared plus 6. That is the equation. Okay? So we have 2 of those on the test that are very similar to that. All right, so on to the circles. Definition of a circle. You can find that in your notes. Okay? Something about equidistant from a point and the circle as a radius and stuff like that. Okay? Graph the following circle, label the center, and give the radius of the circle. So we can get the center from here and here. It's just h and k. All right, so my center is going to be 5, -4. You have to switch the things on the inside. So 5, -4 is here. Okay, that's my center. And then we have to look at the number on the back end here, which is a 4. That is r squared. So in order for me to get my radius, you have to take the square root of that, which is 2. So that means I need to go 2 in all directions from my center, and then I'm just going to try to draw a circle. There's my circle. Okay? In order for you to get the circle on number 9, we have never had any coefficients. That would be the 6 out front. That's a coefficient. Okay, you're not supposed to have coefficients when you're working with circles, so we got to divide them out. And then we can rewrite the equation. X minus 1 squared plus y minus 2 squared equals 36. So center of 1, 2, and a radius of 6. Go ahead and graph that one. Okay, number 10 is one that's kind of the harder one. Okay, so we have to figure out what the equation is, and you're going to have to complete the square. So remember, in order for us to complete the square, we had to group the x's and group the y's and divide by the stuff out front. So if we group the x's, we have this. Oops, so it should be 4y squared minus 24y, and we want the constant on the other side. Okay, so that is grouping everything together, and now we need to divide by a, or divide by the things out in front. So that is a 4. Divide everything by a 4. And then we'll rewrite it so that way we can see how we complete the square. Minus 4x plus y squared minus 6y equals, we're going to have to leave that as a negative 51 over 4 because it doesn't divide evenly. Okay, so then we completed the square with that part, and then we completed the square with that part, and we know we're going to have to add something twice over here because we're completing the square twice. So the one way on the left turns into x minus 2 squared, so that gives me a plus 4 because 2 squared is 4. And then the second one gives me a y minus 3 squared, so that gives me a plus 9 over there. Okay, because 3 squared is 9. So you can throw that in your calculator, the 51/4 plus 4 plus 9, it'll give you 1/4. Okay, so then you can identify your center, which is a 2, -3, and a radius of 1/2, because if I take the square root of 1/4, that is a 1/2. So you'll go kind of a half in all directions. So it's just a little bitty circle there. Okay, so radius of 1/2. Those are the circles, pretty easy. Okay, center is -2, or we got to write equations now. So I'm over here. I'm going to write equations for circles with the following information. We're given a center of -2, 6, and a radius of 4. Pretty easy here. So x plus 2, because that's the h value, plus y minus 6, that's my k value, squared. And then you take that radius and you square it. So I have a 16 over there. Okay, that's the equation of my circle. 12 is pretty easy also. Okay, you could have some on the test where you need a distance formula, because we've had a lot of them on the test, or a lot of them on the homework, where say you're given a point to 0, or the center is 0, 0, and your point on the circle is 3, 4. So then you got to find the distance formula to find the radius, and then plug that into your formula. Okay, the distance formula. You could have something like that on the test tomorrow. Okay. For 12, your answer is x minus 3 squared plus y minus 4 squared equals 9. These are really simple. All right, so that's circles. On to ellipses. All right, definition of ellipse is something about the sum of the distances being a constant, right? We have our ellipse like that. We have a foci there. You draw a point on the circle or the ellipse going from there to there. If I took a different one, they would be the same, okay? Something like that. Should be in your notes somewhere, okay, if you need it. All right, so to graph ellipses, we need to figure out the major and minor axis, okay? Major axis for 14 is the x-axis, because that's the larger number. So wherever the larger number is, that is your x, or your major axis here, okay? And you take the square root of the number in the bottom to get you the numbers that you need to graph, okay? So our center is 0, 0, because there is no h, there is no k. And then that 6 over here tells me I need to go 6 to the right and 6 to the left. That is my major axis, okay? So you can count if you wanted to, or you can take 2 times the 6 to get 12. It's 12 units long, okay? Going from here to here, that's 12 units long. And then the minor axis, we go 4 up and 4 down, so that means that is 8 units long. And then we just kind of try to draw an ellipse, okay? We also want to label foci. All right, and that's the one that people were forgetting in class today. Foci is this, you need this equation. C squared equals a squared minus b squared. It's just Pythagorean's theorem with like a subtraction sign in there, okay? Because the c is used differently here. But you have to remember that a squared is the big number, and b squared is the small number. You just take big number minus small number and square root it, okay? So that's the numbers on the bottom here. So I'm going to take 36 minus 16. So I get c squared is 20. I need c, which is the square root of 20. And if I reduce that, it is 2 square root 5. Okay? So you can put that in your calculator to figure out how far it is actually. It's in between 4 and 5. So it's 2 square root 5, so I'm just going to use that as my label. So you go 2 square root 5 units away from the center. Okay? So that would be right around in here. So this one is 2 square root 5 comma 0. And this one here is negative 2 square root 5 comma 0. Because you go to the right of the focus and to the left of the focus. All right? So that should be good enough for the regular ellipses. Number 15 is the same. 16 and 17, I'll graph those. I'll show you how to set up 16. But it's pretty much the same as the ones above, okay? So think about the way the equations of ellipses are written. We always have a 1 on the right-hand side. So in order for us to get a 1 on the right-hand side, we want to divide everything by 400, okay? So with the numbers here, after we divide by 400, you just reduce the numbers like a fraction. So when you do that, you'll see that you get a 25 on the bottom. So it turns out being this. And then when we do the other one, it ends up being a 16, and we get the 1. So that's our equation of the ellipse to graph, okay? So major axis of 10, minor axis of 8. It's really quick to graph, okay? 5, 5, 4, 4. It's kind of a wide ellipse. And foci would be 25 minus 16, which is 9. Take the square root of that. So you got 3, 0, and negative 3, 0 for your foci. There and there. Okay? So 17 is a little bit harder because it is not centered at 0, 0. Okay? So I'll try to take a little bit more time on this one than the last one. We have a center. You have to pay attention where the variables are, just like on the hyperbolas. Okay? The x comes second, so that means that is your h there, that is your k there. So h is 3, negative 2, which is here. Okay, so that's my center. And then I need to use the number underneath the x to get me my distance from the center. So I go 6 out, so 1, 2, 3, 4, 5, 6. Okay, that's to the right. I go 6 to the left. That's my major axis, so it's 12 units. And then I go 4 up, 4 down. That's my minor axis, so it's 8 units. I'm going to draw my ellipse. Oops. Okay, and then we need foci. So I take big number minus little number, that gets me a 20, so I'll have the square root of 20. I need to go the square root of 20 in either direction from the center, okay? Given my center is the 3, negative 2, and my major axis is the x-axis, I'm going to be going square root of 20 to the right of 3 and square root of 20 to the left of 3. So it could be written like this. 3 plus square root 20, 3 minus square root 20, okay? And the square root of 20 is like 4 point something, so that means I would have 7, I don't know, we'll just say it's 4 point, let's see, 4 times 4 is 16, 5 times 5, so it'd be 4.5-ish, so 7.5, negative 2, and then if we go left, 4.5, so you'd be subtracting 4.5 from there. You get a negative 1.5, comma, negative 2. So that would be here and here. All right? So that is how you do it when it's not centered at 0, 0. You have to use your c squared equals a squared minus b squared to find the value of the foci there, but then you subtract it from the center and you add it to the center depending on which axis is the major axis. Since it's the x-axis being our major axis here, we added and subtracted the square root of 20 from the x-axis. If it were the y-axis, it would be the other way around, okay? So these are my foci. I'm not 100% sure on the decimals, I'm just kind of guessing, okay? That is your graph of one that is not centered at 0, 0, okay? So equations of ellipses here, we have center at 0, 0. So you know that we can have x minus h squared up here, y minus k squared up there, okay? But it's a 0, 0, so the h and k are 0, so really I just have x squared and y squared on top. All right, so x squared here, y squared there. Major axis length is 6 and parallel to the x-axis, so that means that's going to have to do with that one. All right, so we cut these in half, 6 divided by 2, because the 6 is like the whole axis, and we want like a radius. So you cut it in half and square it. So 6 divided by 2 is 3, you square it, that's a 9. That's what goes underneath the x. And then using the other one for the minor axis, you square, or you cut the 4 in half, so it would be 4 over 2, which is 2, and then you square it, so that's a 4. That's the equation of the ellipse, okay? There will be one on the test like that where you have to find the equation with a given center and major and minor axis, okay? So another one up here, we got a center at 2, 4, so that means we have x minus 2 squared over something plus y minus 4 squared over something equals 1. Major axis length of 4 is parallel to the y, so that means the bigger number is down here. Okay, so it would be 4 divided by 2, you cut it in half and square it, that's going to give you a 4 down there. Minor axis goes with the x, so 2, you cut it in half, which is a 1, square it, you get a 1 still. So that's the equation here. The one on the bottom looks kind of goofy, but that's just the way it works out, okay? Because if you went 1 to the right and 1 to the left, you'd have an axis length of 2, okay? And the last one's down here, hyperbolas. Okay, I'll do one of the normal ones and one of the ones that are shifted from 0, 0. All right, and I'll show you how to set up 24. So let's do 22. So remember, we have to figure out if these things are going to go up and down or left and right. Whichever variable is first tells you the direction it's going. So this one has an x value or an x variable first. That means it's going to go left and right because the x comes first. So if we jumped right over to the 23, y comes first, so it's up and down. Okay, so that's going to help you figure out how to start graphing it. All right, so we need to make our box. We called it box method in class. It was exactly like ellipses, but rather than an ellipse, we drew a box. So you have a 3 there and a 2 there. That tells us our x radius, y radius. So we go 3 to the left and 3 to the right for the x value, 2 up, 2 down, and then we drew a box. Okay, so that's the box. Now we need our asymptotes. So my center here, I didn't draw that, but we can draw the center in there anytime. So I draw my asymptotes coming out from the center, going in all directions. And then we can draw our hyperbola. Okay, so it's going left and right. So we need to start from the vertices on the left and the right and just kind of draw it out and try to get close to those asymptotes. I kind of went past it. Try to stay inside them. Okay. 3, 0 is my vertice or vertex to the right because that's where it started, is at 3, 0. And then negative 3, 0 is my vertex on the left because that's where it started on the left. So that's my hyperbola. Okay. Then we needed to find the asymptotes, and since this goes through 0, 0, that's pretty simple for these. It's always b over a. All right, and b is always associated with the y, and a is always associated with the x. So it'd be 2 over 3x. It's y equals 2 over 3x because it's the equation of a line. And the other one is just the opposite slope, so it's negative 2 over 3x. Okay, those are the two equations for your asymptotes. Okay, on to the ones below. Let's do these two, all right? So 24, we have coefficients again. Remember what value we want on the right-hand side of the equal sign. We want this to be a 1, so we divide everything by 100. Okay, and then you're just going to reduce it with the numbers in front, with those coefficients. So 25 and 100 reduce to a 4 on the bottom. So it'd be x plus 1 squared over 4. And then minus, this one's going to reduce to a 25 on the bottom. Y minus 1 squared over 25 equals 1. That's the equation we're going to graph then. The center is not 0, 0. So we got to pay attention to the h and the k. So H is there, K is there. So we have a center of negative 1, 1. That changes it a little bit. So negative 1, 1. And now we can do our box method. So we go 2 left, 2 right from there. And 5 up, 5 down from there. So there and there. Now we can do our box. Okay, and then we draw asymptotes out from the center. And we look at our direction, which we said earlier we're going left and right. We draw our parabola. This one's going to be kind of a wide one. Draw hyperbolas out from those vertices. Okay, so that's that. And this vertex here is a 1, 1. The vertex here is a negative 3, 1. And now we need to figure out the equations for the asymptotes. Okay? So we did this way with point slope form before. We did b over a still, because b is a 5, a is a 2. So you would have 5 halves as your slope. So you did a point and a slope to get point slope form, okay? Or you remembered that wherever we had a y, which was on the left, you wrote that parentheses there. So on the left, you would have y minus 1 equals my slope, and on the right, where you have the x at, you put the x value that's on top of the fraction there. So it's y minus 1 equals 5 halves x plus 1. And then you do it exactly the same except for a negative slope. Okay? I think that that is much easier than remembering point slope form and trying to remember how to plug stuff in, because you're really given the y minus y1 in the problem, and you're given the x minus x1 in the problem also. Okay? Let's tackle this last one here, and then I'll give you a couple other things to look at for tomorrow, just to kind of crunch it in tonight. So we have a vertex of 3, negative 2, which is there, and we have an x value of 6 and 4, so we go 6 left, 6 right, right there, 3, 6, right there, 4 up, 4 down, there, and there. We draw our box. Okay, and then diagonals or asymptotes out from the center. And it's a y equals, so it goes up and down. So my vertex is there, I go up and down, and we can just look and count to that point. So it's 3, 2 for my vertex there. My other one will be 3, negative 6. Just by looking at it and counting to it. Okay? Asymptotes, we do b over a, so that would be a 4 over 6, which we can reduce to 2/3. So we'll have y plus 2 equals 2/3 x minus 3. And then y plus 2 equals negative 2/3 x minus 3. Those are your asymptotes. Okay? That is the hyperbola section. All right, so these are just kind of a lot of things to look at, a lot of things to remember, but they're not overly difficult. You just have to kind of remember when to do what. All right? So a couple other things that we need to remember when we're working on this stuff in this chapter. We need the distance formula. Okay, so the distance formula, let me write that differently. I want lowercase d. Distance equals square root x2 minus x1 squared plus y2 minus y1 squared. That's your distance formula. We also need the midpoint formula. Okay? So midpoint, average of the x's. So add the points together and divide by 2. Average of the y's. That's your point. So you need those two formulas. Okay? Remember, there's going to be a matching on the vocab. And there's going to be a section with that vocab that's kind of like the Conic cards. Okay, but it's kind of like that worksheet where you just labeled it as a circle or ellipse or hyperbola or parabola. So know what the equations look like. Okay, recognize equations. All right, and then like all the algebra stuff where you have to find the equation of a parabola, find the equation of a circle, find the equation of an ellipse, and possibly find the equation of hyperbola. That kind of stuff is on there, okay? You also need to know foci of ellipses. So I had the equation on there earlier. I'm going to write it up here again. Foci for ellipses was c squared equals a squared minus b squared. Okay, it's just Pythagorean's theorem, but you subtract rather than add. And I think that that is everything you need. You'll be given equations for the foci on parabolas, and you'll be given equations for the directrix on parabolas, but everything else you should be able to do just by recognizing the equations of the different forms of conic sections. Okay? So, study hard. If you got questions, come in the morning and we can take care of them before the test. All right? Have a good night, everyone.